Hi guys, we're going to analyze coordinates or analyze polygons in the coordinate plane, and we're going to have to do this. First thing we have to do this is start with slope. So let's take a look at how to find slope. GeoGebra is a great tool to help us find slope, and so let me show you what I'm talking about. I'm going to create 2 points here, and I'm going to create a point at 2, 3 and 6 or 8, 6 and 8 and 2, 4, 6. Okay, and so I draw a line between those 2 points. It looks like this. There's a line. Let's make that line green, shall we? And so I want to find out what the slope of this line is. In order to do that, I'm going to create a third point here. And that point is going to be right here. And here's the reason I'm making that third point. I'm going to create a right triangle. Okay. And see this right triangle? You notice that this is the far from C to B. This is how far I'm going. When I go from A to B, I'm going up 3 units. You notice that? And when I go from A to B, I'm going to the right 6 units. And so slope is defined as, just a moment here, slope is defined as rise over run. What that means is a change in y over the change in x. Or another way of saying that is how far does it go up or down over how far does it go right or left. Now, as we've seen in our GeoGebra picture, if you just count the squares, when you're going up you go 1, 2, 3, and when you're going to the right you go 6. Or you say 6 to the right and 3 up, either way. So let's talk about that. We've got a point here at 2, 3. And we got a point here at 8, 6. So 2, 3, 8, 6. So we just change in y. And this is x1, y1, x2, y2. So y2 minus y1, that gives me the change in y, or the change, how far it moved up or down. x2 minus x1. So y2 minus y1 is 6 minus 3. x2 minus x1 is 8 minus 2. So if you look at that, 6 minus 3 is 3, 8 minus 2 is 6. If I reduce that, I get 1/2. So the slope of this line, which we call m, is 1/2. Now there's 2 things I want you to know about this. And that is a slope of any line that has a slope of 1/2 is going to be parallel to this line. So when I make a line here on the coordinate plane, if I draw a line through these points, like this, and if I draw another line through 2 points and I go like this, oops, make that right here. Now this line also has a slope of 1/2. And either way look at that, if I start here, I go up 1, to the right 2, up 1, to the right 2, up 1, to the right 2. Because this is up 1 means I'm going positive 1, that's my change in y. And over 2 means I'm going to the right 2. So you notice these 2 lines are parallel. So this new line that I just drew has a slope of 1/2, okay? And compared to this other one here, which also has a slope of 1/2, okay? Because they're parallel, all right? Parallel lines have the same slope. And what about perpendicular lines. Perpendicular lines. Well, there's a special case with perpendicular lines. If the lines are perpendicular, like this, okay, then they have slopes that are negative reciprocals of one another. What in the world does that mean? Well, a negative reciprocal of 1/2. Negative means that if it's positive, I make it negative. If it's negative, I make it positive. So negative reciprocal means, first of all, I change the sign. Secondly, reciprocal means I flip the fraction upside down. Very simple. So negative 2 over 1 equals negative 2. So these two, if I have two lines that have slopes that are negative, or 1/2 and negative 2, these lines are going to be perpendicular. And just to show you what I'm talking about, let's try a line on the coordinate plane here. Okay, well, they're going to go down 2 and over 1, down 2 and over 1. Okay, and I'm going to make a okay, let's see if I can make this work here. Alright, notice this line, it wiggled a little bit right at the end there, but I think you get the idea. And you see that these lines, they appear to have a negative, or they appear to be perpendicular to one another, don't they? And if I start here, I go down 2, minus 2, and oh dear, dear, dear. That little wiggle at the end really messed me up there. So I'm going to back up. Let me try this again. And I do apologize for this, but I'm just not willing to make a new video over one little line that went wrong. And oh, I hate when I do that. It's very, very tricky to do this on this thing. So I hope that you will just bear with me a little bit here. There. Alright. So, if I take this point here and I go down 2 and over 1, down 2 and over 1, you see my slope, negative 2 over 1, which is negative 2. Okay? Now the slope of this line is a negative reciprocal to the slope of this line, so that means that these two lines are perpendicular to each other. That's what you need to know about these things. So what does that all mean? Well, let's get rid of this, and I'm going to start with a new deal here. And I'm going to show you, I'm going to give you a QUAD, okay? Quad. I'm going to give you a quadrilateral, and we're going to ask a question about this quadrilateral. And 7, 8, and 9, 5, and 3, 1. So 1 and 4, 1 and 2, 4. There's Q, and I don't like that color, so make it a brighter color. You can see it a little bit better. 1 and 4, 2, 4. There's point Q. Okay. 7 and 8. 2, 4, 6, 7, 2, 4, 6, 8. There's U. There you are. Ha ha ha. There's U. Draw a segment connecting those two. And point A is 9 and 5. Point A is 2, 4, 6, 8, 9, 2, 4, 5. There's point A, and point D is easy. That's 3 and 1 right there. So 3 and 1 That's point D. Make this a little more consistent. Point D. And let me connect those points now. And we want to ask the question now, is QUAD a rectangle? Well, a rectangle is a parallelogram with a right angle, right? Because if one angle is a right angle, then they're all right angles. So a rectangle is a parallelogram with a right angle. So all we have to do is figure out whether, first of all, we have a parallelogram. Well, if it's a parallelogram, that means opposite sides, QU, and DA are parallel. So we want to find out if QU and DA are parallel. So let's find the slope. If the slopes are the same, then they're parallel. So QU, what's the slope of QU? 8 minus 4 is 4 over 7 minus 1 is 6. That's 2/3. That's the slope of QU. Or the slope, let's make that slope. M looks like measure of. So the slope of QU, okay? And change colors here a little bit. Slope of DA. DA is 5 minus 1 over 9 minus 3. So 5 minus 1 is 4, 9 minus 3 is 6, and of course that's 2/3, and that's the slope of DA. So since the slopes are the same, then these two lines are parallel. We can do the same thing with the slope of UA and QD. So the slope of QD, it would be, let's see, 4 minus 1, 1 minus 3, okay? 4 minus 1 is 3, 1 minus 3 is -2. You have to be careful about making sure you get your negative. So that's the slope of QD, okay? And I'm going to change colors here again. Slope of UA, let's see what that is. U8 minus 5 is 3 on top. 7 minus 9 is -2 on the bottom. And so you got -3/2. So these two have the same slope too, and they're parallel. So they are parallel. So we know we have a parallelogram, okay? Now look at the slopes. This is 2/3. If I have a negative reciprocal, that means I flip it upside down and change the sign. Well, isn't that what we have here? So what that means is QU and QD are perpendicular because their slopes are negative reciprocals of each other. Now, if this doesn't make sense to you, that's fine for right now. What we need to do is just remember that you're going to have to practice these. You have to do a few of these before you understand fully what it's all about. So, I'm going to try one more thing here. I'm going to try a triangle, and we're going to find the midpoint of a segment. To find the midpoint of a segment, it's real simple. Midpoint of a segment goes like this: x1 plus x2 over 2, and y1 plus y2 over 2. What does that mean? Well, let's try 2 and 6. 2 and 2, 4, 6. Make that point A. No, that's point A. Point B is 0, 0. That's the origin, so that's point B. And in point C is 4, 0. 2, 4, 0. There's point C. Now, first of all, the midpoint of BC, well, if we do this, add the two x's. You got x equals 0 and x equals 4. So that's 4 over 2. Add the two y's, 0 plus 0, 0 over 2. So the midpoint of BC is 2, 0. Does that not make a little bit sense? That's about halfway in between there. Now, let's try the midpoint of AB. That's this line from here to here. How do I find the midpoint of AB? Well, I use the same formula, x1 plus x2. Remember, A is 2 and 6, B is 0, 0. This is pretty easy, isn't it? 6 plus 0 is 6, 2 plus 0 is 2. So the midpoint of A and B is 2 over 2 and 6 over 2. So this means 1 and 3. Well, let's take a look and see if that works out. There's 1, there's 3. Does that look like the midpoint of that line or that segment? I think so. So anyway, the midpoint of the segment is used by is found with this formula. So if I'm making a triangle on the coordinate plane like this, and I want to find the mid-segment of that triangle like we talked about last time, well, 2, 6, and 4, 0. Okay, 6 and 0 make 3, 2 and 4 make 6, so I've got 1, 2, 3, and 3. There's my midpoint. Okay, there's 3, and there's 3. Okay, so anyway, that's how you do a mid-segment and midpoint. Thank you.